Mathematics, 3rd term, grade 11, chapter 25, probability. Objectives. By studying this lesson, you will be able to solve problems involving the events of a random experiment occurring in two stages using a grid and a tree diagram. Let's see independent and dependent events. What are the independent events? If the occurrence of an event does not depend on the occurrence of another event, then the two events are independent. For an example, we'll consider the random experiment of flipping two coins simultaneously and noting the sides that are face up. It's clear that the side which is face up on one coin has no influence on the side which is face up on the other coin. Next one, what are the dependent events? If the occurrence of an event depends on the occurrence of another event, then they are called dependent events. For an example, the probability of a team winning a cricket match depends on whether the best bowler of the team plays in the match or not. Therefore, the two events of the best bowler playing and the team winning are dependent events. Let's see solving problems using a grid. Exercise 25.1. Question number 1. In a box there are 2 white balls and 4 red balls of the same shape and size. One ball is drawn out randomly from this box and its color is noted. Part A. Write down the sample space of all possible equally likely outcomes. Part B. If the ball is put back into the box and a ball is randomly drawn out again and its color is also noted, draw the sample space of the equally likely outcomes of this experiment on a grid. Part C. If the ball is not put back into the box and another ball is randomly drawn out and its color is noted, draw the sample space of this experiment on a grid. Part D. For the experiments described in Part B and Part C above, find separately the probability of the two balls taken out being of the same color. Part A, just one ball is taken. What's the sample space? S for sample space. S equals 2 white balls W1, W2, 4 red balls R1, R2, R3 and R4. Part B, if the ball is put back into the box and the ball is randomly drawn out again and its color is also noted, draw the sample space of the equally likely outcomes of this experiment on grid. Label the axes as first ball and second ball. What are the colors? W1, W2, R1, R2, R3 and R4. You are getting the same color for the both axes. And is this independent or dependent? This is independent. Why is that? You are replacing the first ball back. Then you have to mark the all outcomes on the grid. I will explain Part C later. Go to Part D. For the experiments described in Part B, find the probability of the two balls taken out being of the same color, white, white and red, red. What are the possibilities altogether? 16 plus 4, 20 out of 36. What is the sample space? 36. 6 times 6, 36. 20 over 36 is equal to 5 over 9. Part C. If the ball is not put back into the box and another ball is randomly drawn out and its color is noted, Draw the sample space of this experiment on a grid. You are not representing the ball again. The events are dependent. Then we can't mark on the main diagram. If you get W1 first time, you can't get W1 again. If you get W2 first time, you can't get W2 again. Like this, you can fill this grid. Part D. For the experiment described in Part C, find the probability of the two balls taken out being of the same color. Same color, white, white and red, red. What are the possibilities altogether? 12 plus 2, 14. 14 out of 30. You can simplify it, 7 over 15. Exercise 25.1, question number 4. In a dish, there were 3 milk toffees, 2 orange flavored toffees and 1 tamarind flavored toffee, which were all the same size and shape. Sandra randomly took one of these toffees and tasted it. Later, she randomly took another one and gave it to her friend Jessie. Part A. By taking into consideration the flavors of the toffees, represent the relevant sample space of equally likely outcomes on a grid. Part B. Using the grid, find the probability of each of the following events. The events are given in our question. They are both getting toffees of the same flavor. Second one, only one person getting a milk toffee. Third one, Jessie getting a tamarind flavored toffee. Part A, you need to draw the grid. Label the X's as Sandaru's toffee and Jessie's toffee. What are the flavors here? 3 milk toffees, 2 orange flavored toffees and 1 tamarind flavored toffee. I have labeled both of these X's as M1, M2, M3, O1, O2 and T1. She took 1 toffee and tasted it. Altogether, she took 2 toffees. Are they dependent or independent? These are dependent. Why is that? Because she didn't replace the first toffee. She tasted it and gave another one to her friend. Then we have to mark the outcomes without main diagram. Part B. Using the grid, find the probability of each of the following events. First one, both getting toffees of the same flavor. Same flavor can get milk toffees and can get orange flavored toffees, but we can't get tamarind ones. Altogether, how many possibilities are there? 6 plus 2, 8. 8 out of 30. What is the sample space? 6 times 6, 36. 36 minus 6 is equal to 30. Then we can get 8 out of 30 is equal to 4 out of 15. Part 2. Only one person getting a milk toffee. This part, if Sandaru is getting milk toffees and Jessie is not getting milk toffees. This part, if Jessie is getting milk toffees and Sandaru is not getting milk toffees. How many possibilities are there? 9 plus 9, 18 out of 30 is equal to 3 over 5. Part 3, Jessie is getting a tamarind flavored toffee. This part, Jessie is getting tamarind flavored toffees and Sandaru is getting other flavored toffees. How many possibilities are there? 5 out of 30 is equal to 1 over 6. Let's see solving problems using tree diagrams. A tree diagram can be used to find the probabilities of events related to a random experiment having many stages. In this lesson, we will consider only random experiments having 2 stages. Exercise 25.2, question number 1. In a box with 10 bulbs of the same type, 3 are known to be faulty. Nimal randomly draws out one bulb from the box and checks whether it is faulty. Without replacing the first bulb, he draws out another bulb and checks whether it is faulty. First question represents the sample space of the above random experiment in a T-diagram. Second one, Nimal states that the events of the first bulb being faulty and the second one being faulty are dependent events. Given reason, explain whether this statement is true or false. Third one, find the probability of each of the following events using the T-diagram. Part A, both bulbs being faulty. Part B, exactly one bulb being faulty. Part C, at least one bulb being faulty. We need to draw the tree diagram. Nimal takes the two bulbs without replacing the first bulb. Take the first bulb. It can be divided into two parts as not faulty and faulty. There are 10 bulbs and 3 are known to be faulty. Then, what are the probabilities? 7 over 10 and 3 over 10. Without replacing the first bulb, he takes the second bulb. Again, it can be divided into two parts as not faulty and faulty. If he takes a bulb being not faulty in second time, you can get 6 bulbs out of 9 as not faulty and 3 bulbs out of 9 bulbs as faulty. Again, this should be divided into two parts as not faulty and faulty. If he takes a bulb being faulty in second time, you can get 2 bulbs out of 9 bulbs as faulty and 7 bulbs out of 9 bulbs as not faulty. Second question, Nimal states that the event of the first bulb being faulty and the second one being faulty are dependent events. Given reasons, explain whether this statement is true or false. That's true. Why is that? Because not responding the first bulb, so probabilities are not same. Third question, find the probability of each of the following events using the tree diagram. Part A, both bulbs being faulty. First bulb faulty and second bulb faulty. You can take the probabilities by multiplying. Multiply 3 over 10 by 2 over 9 equals 3 times 2, 6, 10 times 9, 90 is equal to 1 over 15. Part B, exactly one bulb being faulty. Not faulty, faulty and faulty, not faulty. First you should multiply and then you can add. Multiply 7 over 10 by 3 over 9 plus within brackets multiply 3 over 10 by 7 over 9. 7 times 3, 21, 10 times 9, 90 plus 3 times 7, 21, 10 times 9, 90 equals 21 plus 21, 42 over 90 is equal to 7 over 15. Part C, at least one bulb being faulty. Now take the probability of not faulty, not faulty and subtract from 1. Multiply 7 over 10 by 6 over 9 and subtract from 1 equals 1 minus 42 over 90 equals 1 means 90 over 90 minus 42 over 90 is equal to 48 over 90, which is 24 over 45. Exercise 25.2, question number 5. X and Y are two drugs given for the same illness which have 90% and 80% effectiveness respectively. If a person does not recover from the illness by using one of the drugs, then the other one is also given. If these two fails, then a surgery is done. First question, find the probability of the patient recovering after both drugs are given. Question number 2, find the probability of a patient having to undergo surgery. Okay children, we need to draw the tree diagram to find the probabilities. There are two drugs as X and Y. Now take the first drug. It's mentioned that X drug has 90% effectiveness to recover the illness. Then X can be divided as recovering and not recovering. 90% can be recovered and 10% can't be recovered. And it's mentioned that if a person does not recover from the illness by using one of the drugs, then the other one is also given. Then the other drug has 80% effectiveness to recover the illness. 80% can be recovered, 20% can't be recovered. Now go to the first question. Find the probability of the patient recovering after both drugs are given. X can be recovered 90% and Y can be recovered 80% by 10%. Now take the probability. Write these as fractions. 90 over 100 plus within brackets 10 over 100 multiplied by 80 over 100. Now you can simplify 90 over 100 plus 8 over 100. 98 over 100. You can simplify 49 over 50. Now go to the second question. Find the probability of a patient having to undergo surgery. Both of these drugs can't be recovered, they are doing a surgery. Then not recovering, what's the probability? 10 over 100 multiplied by 20 over 100. You can simplify it. 2 over 100 is equal to 1 over 50. Mathematics Grade 11 Part 3. Now you can do these exercises. These exercises are in your textbook. Review exercise. Exercise 25.1. Exercise 25.2. Thank you everyone.